In this question, f double prime, second derivative of f is given 2 et plus 3 sin t, and two initial conditions, f at 0 equals 0, when t equals 0 the function is 0, and f at pi equals 0 given, and we have to find the function f. Okay, so this is the second derivative. We want to take antiderivative of this function, we get the first derivative. Then f prime from double prime, f prime t equals 2 is just constant 2. Give me a function whose derivative is e to the t. It's like e to the x. Okay, we know e to the t, derivative of e to the t is itself, plus 3 is there times sin t. Give me a function whose derivative is sin t. That's obviously cosine t, and we know derivative of cosine t is negative sin t, but there is no negative, so we have to put negative here. Then times 3 times negative cosine t, and plus 0 is always there, so we can write down plus c. Derivative of c is 0. Let's rewrite this function, f prime 2 e to the t plus minus minus 3 cosine t plus c. Okay, and let's look at to determine c. We want to use the initial value, but the initial values are given for f. We have f prime, so none of these can be used now. Now we want to find antiderivative one more time. This is f prime. Let's take antiderivative. We get function f. Okay, the function is 2. Give me a function whose derivative is et, which is et, because derivative of et is et, minus 3 is there. Give me a function, it's a times, give me a function whose derivative is cosine t, that's sin t. Derivative of sin t is cosine t, is a times, plus give me a function whose derivative is c. Just think about like 5 or 7. Okay, so 5x, in this case 5t, ct. Derivative of ct is just c. It's like 5x, derivative of 5x is 5. Okay, plus 0 is always there, so plus we can write another constant d, arbitrary constant d. Now we need to determine the values of these two constants c and d using these two initial conditions. Let's use f0 equals 0 first, because that one is easier than pi. It doesn't matter which one you use first though. So using f at 0 equals 0, f is 0 when t equals 0. Okay, f is 0 when t equals 0, so 2 times e to the 0, e raised to 0 is 1, minus 3 times sin 0 is 0, plus c times 0, which is 0, plus d. So basically we have 2 minus 0 done, just 2. Move this 2 over, subtract 2 from both sides, we get d equals -2. So d is done. Now we want to use the second initial condition to determine c. Okay, using f at pi equals 0, we get, so f is 0 when t equals pi, so we're going to use here, so f is 0 when t is pi, so 2 e to the pi. E to the pi is just a constant, we don't have to find, just e to the pi, just leave as it is, minus 3 times sin 0, sorry, not 0, pi. Our t is pi. Let me write in this way. This is t value, t is pi, and this is f value. Okay, sin pi. Sine pi also 0, and 3 times 0 is 0, plus c times pi, because t is pi, so c times pi constant, plus d is found -2, so plus -2, which is -2. And let's isolate c from here, so we need to move this to the left side, subtract 2 e pi and plus 2, so that's r. Move this over, that means subtract negative plus 2, -2 becomes plus 2, so c pi equals -2, other side 2 minus 2 e pi. Now to isolate c, because c is the constant we are looking for, divide by pi, so c equals 2 minus 2 e to the pi, everything divided by pi. Okay, so c is a big constant and d is -2. We plug these two into the function and we recover the function. Thus e of t is 2 e to the t minus 3 sine t plus ct, plus c is a big constant, 2 minus 2 e pi all over pi ct plus d is -2. So this is the final answer. Okay.